Alright, let's talk about recovery binary search tree. So you are given the root of a binary search tree where the value of exactly 2 nodes of the tree was swapped by mistake. So recover the tree without changing its structure. So this is 321 is actually how I use the InOrder traversal to print. So this is 321 and this is 1324, right? So I will have to know where is the node placed by mistake. And this is definitely 3 and 1 are definitely placed by mistake. And this is 3 and 2, right? And let me just finish the InOrder method. So if no equal to no, I will just return. Then I will just keep going to the left of the tree. Then I need to add my value into my list. Then I need to go on my right of the tree. And this is the solution for InOrder. And recovery, I definitely need a list of tree node. I'm gonna call list and use a read list for library. And I'm going to say if root equal to no, I would say okay. Now I just return right away. Other than that, I need to know which is my choose. Okay, I'm calling this function first. I'm going to call root and list, and I need to know which of the tree node need to swap, right? So tree node x equal to no first, and y equal to no. Now, after I traverse the tree, and I already know how is my list for now. So I will say for in I equal to 0, I will less than list of size I plus plus. So since we are compare the value I and I plus 1, so we need to compare the two values I and I plus 1. So I can actually say, okay, this is list of size minus 1. So if list of get at I is greater than list of get at I plus 1, which is value, sorry, and I need to make it consider. So which is the value before is greater. So this is definitely swap and this is definitely swap. So in this case, I'm storing my I plus 1 first. So this dot get at I plus 1 will be the y, and if x is equal to no, and I will say okay, x is better be this dot get at I. So why do I have to do this? Because if I don't have this if statement, right, the y will keep the x will not change. Will keep changing. Sorry, if I don't have this if statement, the x will keep changing, and the y will keep changing as well. But we need to be we need to know which node is definitely wrong, and this is definitely 3. 3 is definitely wrong. So in this case, 1 3, okay, this is good. 3 2, okay, 3 2 is definitely wrong, right? I is greater than I plus 1, so 3, I will store 3 into my x, and 2 will become my y. And when I go on the next one, 2 4, okay, 2 4 is not actually valid for if statement, so I would just know 3 and 2 are definitely wrong. But in this case, 3 2 are wrong, but 2 1 are also wrong, right? So I don't have to keep updating my x, and this is pretty much the solution. And one more stuff, you need to swap, right? So if x is not known and y is not known, then I want to swap. So this will be x dot val, and x dot val become y dot val equal to 10, and I will just return right away. and this will be the solution, and they just run it to see if I have any error, and I do. So I forgot the list, and they just run again, and this is virtual pass, and yeah, the test case are passed. So let's think about how I need to spend on the time and space complexity. So all of n for the time, for sure, right? You traverse, and you also use the InOrder. That will be all of n for time. And space is all of n. You store every tree node into the list, and this is the easy way to solve this problem. And if you want to have different solution, probably you can try Morse, and this is a little bit harder. You need to connect your children to your parent. I mean the ancestor. So which is 2 dot right will connect to 1, and you need to know which one is definitely wrong, and this definitely has to read the algorithm. And I will just pause for a second, and I will just move on the next question. So if you feel it's helpful, then press a like, subscribe if you want it, and leave a comment if you want. And I'll see you next time. Bye.